Now we move on to page 4 of the worksheet. So on this page, we have 2 word problems. This first word problem at the top, and then another one towards the bottom of the page. So again, there's answers and an answer key at the bottom. Okay, so what does the first example say? So it says $3,000 is invested into an account with an APR of 2%, and calculate the amount in the bank after 6 years if interest is compounded. Right, so we are working with compound interest, so we want to use the compound interest formula. And another thing is that it specifies different times that it's compounded. So what is the compound interest formula? So it's A is equal to P times 1 plus R over N to the NT. Okay, so in each of these parts, we have to determine the parameters. Right, so what's given in the problem? So the $3,000 is the initial amount. So that means what is the initial amount? That's P. So P is 3,000. So what else is given? The APR is 2%. So that's the interest rate. So that's R. However, we need to represent 2% as a decimal. So 2% as a decimal is 0.02. So that means that R is 0.02. And then finally, the amount of time that we allow it to grow is 6 years. The time is T. So T is 6 years. Okay, so all that's missing is N, and N is given by each of the different parts. So N is how many times it compounds in a year. So annually means 1 time per year. So that means that N is equal to 1. Quarterly means 4 times per year. So because there's 4 quarters in a whole, so quarterly means 4 times. So N is equal to 4. There's 12 months in a year. So N is equal to 12 here. Okay. So that means for each of these, we just plug N into the given formula. So we just plug in and calculate. So what do we have? A is equal to P is 3,000. 1 plus R is 0.02 divided by N, which is 1, raised to the NT. So 1 times T, which is 6. Okay. So now we calculate. So 1 times 6 is just 6. And let's also calculate this thing. So 1 plus 0.02 divided by 1. 1 plus 0.02 divided by 1 is equal to 1.02. 1 times 6 is 6. And then now we can calculate this thing. So I can calculate this all at once because the calculator will follow the order of operations. 3 times 1.02 raised to the 6th power. and we get 3378.49 rounded up. Which we see is the correct answer. Okay, so now we just calculate the other ones following the same procedure. So the second one is A is equal to 3,000 times 1 plus 0.02. Now n is 4. So what do we have? Calculating the thing in the parentheses, 1 plus 0.02 divided by 4 is 1.005, and then 4 times 6 is 24, and then putting it all together, we have 3,000 times 1.005 raised to the 24 power, which is 3381.48. Which again matches. Okay. And then the third one, n is now 12. But everything else is the same. So we have this 0.02 divided by 12 to the 12 times 6. Again, first let's calculate what's in the parentheses. So 1 plus 0.02 divided by 12 is 1.001666667. So let's round that, but don't round it too much, otherwise you get rounding error. So let's do 1. How many zeros is that? 2 zeros. Okay, so let's round it as 1.00167. And we have to do 12 times 6. 12, times 6 is 72. So the exponent is 72. And what do we get? So 3,000 times 1.00167 raised to the 72 power is 3382.96. What was it again? 3382.96. So the reason that it's off a little bit is because we rounded this number up, and so it increases the final result a little bit, but that's not too important. And if we use the exact value, then you would get the exact answer. So there's some rounding error here. Okay, so finally we're asked to compound continuously, and so the continuously compounding formula is a different one. It uses the exponential e. So continuously compounding means that the formula is a is equal to P times E to the RT. So again, this uses a different formula. Okay, so the parameters are the same as before. So P is 3000, R is 0.02, and T is 6. So we just plug that in. 3000. E is not a variable, it's a number. It's the natural number. R is 0.02, T is 6. Okay, so now let's calculate this. So 0.02 times 6 is 0.12. And then now let's calculate it. So 3000. So the number E is in yellow here above the division symbol. So to access it, I need to use the second button and then press this to get E. And then I raise this to the 0.12 power. And then what do we got? 3382.49. Okay, so if all the calculations are done correctly, and all of these amounts should be about the same. There shouldn't be that much difference between them. And that just means that it doesn't really matter how many times you compound interest within the year. It's not going to make that much of a difference. But typically, continuously compounding will be the most. And this is just because of rounding error. Okay, so let's move on to the final example. So what does it say? It says a scientist begins with 100 milligrams of an unknown substance that decays exponentially. So we know that it decays exponentially. After 35 hours, 50 milligrams of the substance remains. How many milligrams is left after 54 hours? Okay. So we know that it decays exponentially. So we have to use the P equals, so A equals P times E to the RT formula. So we know the initial amount is 100 milligrams, so this is the initial. So that's P. After 35 hours, 50 milligrams remains. How many milligrams is left after 54 hours? Okay, so it doesn't tell you the rate, and there's two different times. So R is unknown. Okay, so what this means is I have to do this problem into two parts. So first part is to find R. And I do that with this and this. So this would be T1, so that's the first time. And this would be the final amount for that time, so that would be A. Okay, so what do we have? So plugging in, you get 50 is equal to 100 times e to the r times t, which is 35. So 50 divided by 100 is 1/2. E to the 35 times r. Okay, so now I have to cancel the exponential e by using the natural log. Okay, so this is going to be a little bit complicated, so there's a slightly easier way to do it using the half-life formula, because the initial amount versus the 50 is exactly 1/2. So since 50 is 1/2 of 100, we can use what's called the half-life formula. Which is the following. So r is equal to the minus natural log of 2 over the time. So we can use this formula to calculate r. Okay, so let's do that. So r is minus the natural log of 2 over 35. So the natural log function is part of the calculator, so let's use the calculator. So we want to calculate the negative natural log. The natural log key is this button here, ln. So natural log of 2 divided by 35, which is minus 0.0198. Okay, so that's the first part. Now I have to use that to calculate when the time is now 54 hours. So we use the formula again. So A is equal to P is the initial amount, which was 100. Right, so this is P times E to the R, which we now know is minus 0.0198, and then the new T is 54, and okay, so we have minus 0.0198 times 54 is negative 1.0692. What was that again? Negative 1.0692. Okay, so we get 100 times e raised to the, so let's just use the answer from the previous calculation, 34.33 milligrams, which we see is the correct answer. Okay, so here again we can use the half-life formula to calculate R to make things a little bit easier instead of working with the equation here.